When you work on planning a software project, one of your first steps is design and architecting the software. Software architecture is a high-level software design that allows software teams to sketch out the big picture and begin preparing a prototype. Here are the important steps that you perform in architecting. 1. Requirements. Functional and non-functional requirements are the baseline to architecting the product to customer expectations. Tools like mind mapping helps create high-level requirements, map functional and non-functional requirements to shape scope of work. 2. Design strategy. At this level, you start collaborating with the team on questions like, what if you build a perfect design? Are you well equipped to do that? Are there any risks out there? As you go on thinking of answers to these questions, maintain a shared documentation. 3. Divide into layers. Start thinking about each layer in your design. Depending on your approach, you might think of layering vertically or horizontally, where vertical layering focuses on individual features in separate components, and horizontal layering focuses on components themselves. Start modeling your architecture as you go with modeling tools out there. 4. Prototyping. Prototyping is a concept of modeling the behavior at a small scale. By frequent feedbacks from customers and other stakeholders, and frequent iterations, you can keep building until you have close to perfect product. Documentation, modeling, and single source of codebase can help maintain your prototype and learn from your mistakes during this process before delving into building the real product. 5. Well-architected framework. Considerations such as performance, scalability, security, resilience, and extensibility should be considered to build a robust, modern, and well-architected framework. Here are some architectural best practices that you should consider while designing your product. 1. Separation of concerns. Minimize interaction points between internal layers, such as drawing clear boundaries between business model and implementation. 2. Encapsulation. Means hiding parts of the application from other parts to make them untangled and make the software evolvable. 3. Single responsibility principle. Each code-based component should have exactly one responsibility over software functionality. This helps in making code components reusable and replaceable. 4. Don't repeat yourself. Avoids duplication of functionality and reduces failure. 5. Reduce waste. To avoid having unused functionality and wasted time, design only those components that are necessary. There are various types of architecture patterns or designs that you can consider while building your product. I'll be covering each of these architectures in more detail in separate videos, and will provide links in the description below. 1. Client-server architecture. The application is based on a server and can support numerous clients. 2. Monolithic architecture. Monolithic is the traditional approach to building a self-contained application, often called a single-tier application. The application contains 3 main components that together create one codebase: the user interface, UI, the business logic, and the data interface. 3. Multi-tier architecture. The application is divided into layers that each carry its dedicated functions, like implementing business logic, data layer, and presentation layer, etc. 4. Microservices architecture. Microservices architecture arranges an application as a collection of loosely coupled, fine-grained services communicating through a lightweight protocol. Each microservice is a self-contained component that can be developed, deployed, and maintained separately. 5. Event-driven architecture. Event-driven architecture, or EDA, is a software design pattern that allows systems to detect, process, manage, and react to real-time events. These events are a change in state of the system. 6. Serverless architecture. Serverless architecture is an event-driven and query-driven technology solution that allows application developers to create efficient cloud environments with all the computing resources needed to run a seamless development process. That concludes our today's video on architectural considerations, patterns, and best practices. Thank you for watching. Comment below if you want me to cover any more topics like this. Please like, share, and subscribe to this channel for more videos. Happy learning!